Hi guys, and welcome to another video. Today we're going to be looking at functions and finding the coordinates of the turning point of a parabola by using the formula and by completing the square. So I'm going to show you two methods in today's video lesson. And the problem that we're going to be looking at is from the KZN June 2019 paper. Question 6 reads as follows. It says, given the functions p of x equals to minus 2x squared minus 5x plus 3 and q of x equals to mx plus 3 and the angle of inclination of q is 135 degrees. So we're only going to focus on the function p of x. So we're going to go straight to 6.2. And I will cover sketching of the graph in another video lesson. So in today's lesson, I want to cover finding the coordinates of the turning point. So let's look at 6.2. So in 6.2, we have p of x. So let's write down p of x equals to minus 2x squared minus 5x plus 3. So method 1 to find the coordinates of the turning point would be as follows. So let's look at that. So what we're going to do is we're going to use the formula x equals to minus b over 2a. So let's substitute the values b and a into this formula. Now, in order to get the values b and a, remember that p of x has to be in the standard form, which is ax squared plus bx plus c, which it is in already. Therefore, a is equal to minus 2 and b is equal to minus 5. So therefore we have minus 5 all over 2 times minus 2. And this would give us minus times minus 5 is 5 and 2 times minus 2 is minus 4. So we're left with negative 5 over 4. So therefore x is equal to minus 5 over 4. And this is also called our axis of symmetry. Now, in order to find the y value, we have to substitute the x value into our original equation, which is p of x. So basically, y equals to p of minus 5 over 4, which will equals 2. So let's substitute minus 2 times minus 5 over 4 all squared minus 5 times minus 5 over 4 and plus 3. Let's put that in our calculator. 3, which is equal to 49 over 8. Therefore, we can conclude that the coordinates of the turning point is minus 5 over 4 and 49 over 8. Now, they could have asked us a question indirectly to find the turning point as follows. They could have said, instead of saying determine the coordinates of P, they could have said determine the range of P. Now, if they're saying determine the range of P, we are still required to find the coordinates of our turning point. And one thing that we have to remember before finding the range is in this particular function, remember that a is less than 0. Therefore, we are going to have a maximum value. Therefore, turning point is going to be there. So P and Q, coordinates of my turning point, will be there. So therefore, the range of this particular function, remember, this graph will only exist below that y value. That's why we call it the maximum value. So in this case, the range will be y less than equals to 49 over 8. That's because we have a maximum value. And there you go. I've explained it here by drawing a picture of what this graph will look like. Now let's look at the second method of finding the coordinates of the turning point. So let's write down p of x once more. So p of x equals to minus 2x squared minus 5x plus 3. Now when you are going to be completing the square to find the coordinates of your turning point, the first thing that we have to do is make sure that the coefficient of x squared is positive 1. So we're going to remove minus 2 as a common factor. And we're going to be left with x squared plus 5 over 2x and minus 3 over 2. And let's double check. If I have to take minus 2 into the brackets, minus 2 times x squared is minus 2x squared, minus 2 times positive 5 over 2x. 2 and 2 would cancel and I'll be left with minus 5x. Minus 2 times minus 3 over 2, minus times minus is plus, 2 times 3 over 2 will be positive 3. Now when we are going to be completing the square, we need to remember the following formula. We must add and subtract half the coefficient of x all squared. Now what is the coefficient of x? The coefficient of x is 5 over 2. Therefore, this is now going to become plus minus half times positive 5 over 2 all squared. And what's that going to be? What's half times 5 over 2? So it's going to be plus minus 1 times 5 is 5, 2 times 2 is 4. So we got 5 over 4. So we're going to add and subtract 5 over 4 all squared. So let's look at that. Minus 2x squared plus 5 over 2x. And now let's add 5 over 4 all squared, subtract 5 over 4 all squared, and let's write down minus 3 over 2. Now let us simplify. So first of all, what is the completed square form or the turning point form? Well, the turning point form, we want to write it as follows. P of x equals to a into x plus p all squared plus q. And remember that the turning point will be, in this case, minus p and positive q. So let us complete this particular question. So we're going to write minus 2 into. So here we got x squared and plus 5 over 2x plus 5 over 4 all squared. So we're going to be left with x and positive 5 over 4. So it's going to be plus 5 over 4. Remember that this is positive, so that goes there, that goes there. Remember, without the squares. This, you're going to put it into your calculator. So let's put that in the calculator and let's see what we get. That's minus 49 over 60. Minus 49 over 60 equals 2. So now let's take minus 2 into the brackets. So that'll be minus 2 into x plus 5 over 4 all squared. Minus times minus is plus. 2 goes into 2 one time and 2 goes into 16 8 times. So that's going to give us 49 over 8. So therefore, P of x in the turning point form is minus 2 into x plus 5 over 4 all squared plus 49 over 8. Therefore, we can conclude that our turning point, remember we want to change the sign there, x plus 5 over 4 equals to 0, means that the axis of symmetry will be minus 5 over 4, and the y value of your turning point will be positive 49 over 8. And once again, if we were asked for the range, remember a is negative, so we have a maximum value So the coordinates of the turning point will be minus 5 over 4 and 49 over 8. So therefore, the range will be y less than equals to 49 over 8. Learners, if you haven't subscribed already, don't forget to subscribe to JL Maths, like my Facebook page, Justin Lazarus Mathematics. You can check out all the videos on jlmaths.com, and I'll catch you in the next video.